Okay, so today we're going to look at equilibrium shifts and phase changes. So first of all, let's do a quick review of solids, liquids, gases. This should be a review from middle school science and from physical science. Solids are tightly packed. They have a high density. I'm just going to put a D for density. And compressible relatively. They have a low energy. Liquids have a definite volume and shape. Let's put definite melting point for these. Let's put definite boiling point for liquids. They have a high density. Liquids do. They are relatively incompressible, especially in comparison to gases. Gases have high energy. They are compressible. They take the shape of their container. They move faster. That goes along with the high energy. And just let me go over those. Crystals, of course, would be a solid. They have definite particle arrangement. If particles are random, I'll just call it an amorphous solid. Okay, so let's look at something called Le Chatelier's principle. And this just says that a system at equilibrium. From now on, when I write out equilibrium, I'm going to do EQBM instead of writing that whole thing out. Will remain at equilibrium until there's a stress applied. So the most common one that they use for this is just the equation liquid plus heat energy yields vapor. So if this is in a closed container, so if we have like a jar that this is in, and we're going to say that the jar does have the lid on it. If we have liquid, we have some, and I'm just drawing little flames, but it's not really going to have like that much heat applied to it, but just to know that there's a heat, good heat. This should go up, make vapor that's going to condense, come back down as rain, and it will just continue to do that all the time as long as there's a heat energy and there's a liquid and it's in a closed container. If you take away any of that stuff, then you'll get what's called an equilibrium shift. If you see an arrow going one way and one going the other way, it's in equilibrium. That means that it's balanced out. It's just going to continue to do that liquid to heat energy to vapor and then go back and forth. So we have something called equilibrium shifts. So with this one, if you add liquid, and usually I try to think of it like it's kind of can't move past the edges. So if you add something here, it can't move that way, it's gotta push over this way. So that means it's going to shift to the right. If you remove liquid, so if you take away some of this liquid, so this is that liquid space, if you take some of it away, it's gonna make it move to the, shift to the left. If you add vapor, remember it can't go past this end, so it's gonna have to move that way, so it's gonna move, shift left. If you remove vapor, okay, so this is like the spot for vapor. If you remove some of it, then it's gonna have to shift over that way, so it's gonna shift to the right. If you increase the temperature, okay, so we're gonna increase the temperature, so this is kind of the temperature's place right here. If you increase it, it can't move back, it's gotta shift to the right. If you decrease the temperature, then it'll shift to the left. So that is equilibrium shift in Le Chatelier's principle. It's pretty easy. You will probably see some equilibrium shift questions on your test. Just kind of think of it like I told you, how it's kind of at the end and you just got to take away from the side. So if you take away something like over here, it's going to, like if you take away the liquid, it's going to shift it that way.